Good evening everyone and welcome back to my channel. Today is a bit of a unique video for my channel because normally I just go over things that are in the maths curriculum, but today I just thought I'd do something that I find quite interesting, which is proving the quadratic formula. So the first thing I'll say is that whenever you look at any formula, whether that's in physics or maths or anywhere, you always have to remember that every formula comes from somewhere. Like, these formulas all mean something, and the quadratic formula is included in that. So that's what I'll be going over today. So to start off, whenever we look at a quadratic, because remember, what is a quadratic formula? It solves a quadratic. So let's say we have a quadratic of let's say x squared plus 3x plus 2 equals 0. Okay, basic quadratic. Now, how can we solve that? How can we solve for x? So the first thing we can do is we can factorize. Another thing we can do is use the formula. And the third thing we can do is we can also complete the square, or solve the square. So the easiest one for something like this is just factorizing. So that's just going to be two numbers that multiply to this number and add to this number. So that's just going to be 1 and 2, because 1 times 2 is 2 and 1 plus 2 is 3. So it's going to be x plus 1, x plus 2. Nothing new. And so when x plus 1 equals 0, x equals -1. And when x plus 2 equals 0, x equals -2. Nothing new there. We all know how to solve like that. Another way we can solve is using the formula. So let's substitute in. Normally the formula is -b plus minus the square root of b squared, take away 4ac all over 2a. So let's substitute. -3 plus minus the square root of 3 squared, take away 4 times 1, which is here, remember, times 2, all over 2 times 1. Well, probably a pretty easy calculation, but let's put that in my calculator. Speed things up, -3 plus the square root of 3 squared, take away 4 times 1 times 2, all over 2 times 1. So that gives me that x is equal to -1, or when I switch this sign around to negative, x also equals -2. Sorry, my paper. And that's the exact same answer that we get from factorizing. So these different methods, they should still all give us the same answer. And then completing the square, we all know how to do that as well, hopefully. So we get the x squared and we half this value here. So it becomes x plus 3 over 2, and we get rid of one of the x's and square it. So just to see what I've done here, turns x into an x squared and half this and squared that all. And then we subtract this value squared, which is called 9 over 4. And then we add on this thing, plus 2. That means that x plus 3 over 2 squared, sorry, this equals 0. This means that x plus 3 over 2 squared minus 9 over 4 plus 8 over 2 equals 0. So x plus 3 over 2 squared this is going to be 6. Let's say 16 over 4 plus 7 over 4 equals 0. No, sorry, this is 8. I'm just being dumb. 8 over 4, yeah. So that's going to be minus 1. Minus 1 over 4 equals 0. Okay. So that means that x plus 3 over 2 squared equals a quarter. And x plus 3 over 2 equals plus minus the square root of a quarter, which is, that means that x plus 3 over 2 equals a half, square root of a quarter. And that also means then that plus minus, that means that x equals either a half minus 3 over 2, which equals negative 2, negative 1, sorry, or negative a half minus 3 over 2, which means that x equals negative 2. And you'll see all these answers are the same for each of these methods, because these are just different methods. They all should give us the same answer, because that's maths. So what I want you to pay attention to here is that although I've represented these 3 methods that we should be hopefully familiar with, the formula and completing the square are actually the same thing. And let me show you what I mean. So first of all, let's just use a more complex completing the square, and then we can move on to that. So let's say we have something like 4x squared plus 8x, no, actually plus 10x plus 6 equals 0. So in this case, when we're solving the square, what do we do now? We take out the factor of this, because we want it in the form where the coefficient of x squared is 1. So we do 4 bracket x squared plus 10 divided by 4, which is 5 over 2, x plus 6 equals 0. All good? Because that means if we multiply that by 4, we get 4x squared. Multiply that by, this is a 2, it looks a bit dodgy. Multiply that by 4, we get 10x. And yeah, so it's the same thing. And now we can complete the square on this. So take 4 outside the bracket. Oh, this camera's not focusing. 4 outside the bracket. And then x plus 5 over 4, we half it. All squared, subtract that squared, so subtract 25 over 4, over 16, sorry, plus 6, so this is, plus 6 equals 0. And now we can multiply the 4 again. So 4x plus 5 over 4 squared. What's negative 25 over 16 times 4? Let's quickly put that on my calculator because I can't be bothered to do that in my head. Negative 25 over 4. Negative 25 over 4 plus 6. Well, 6 is the same as 24 over 4, which equals 0. So that means that 4x plus 5 over 4 squared minus a quarter equals 0. So 4x plus 5 over 4 squared equals a quarter, which means that x plus 5 over 4 squared equals a quarter divided by 4, which is going to be 1 over 16, which means that if we square root that, sorry, we get x plus 5 over 4 equals plus minus square root of 1 over 16, which means that x plus 5 over 4 equals plus minus a quarter. And then x equals either a quarter minus 5 over 4, which equals -1, or a quarter, negative a quarter minus 5 over 4, which equals -3 over 2. And that's our answers for here as well. And we can prove this by factorizing this, and we should get the same answer. So if we get this and factorize it, first we're going to multiply this by this, and we get 24. So we need two numbers that multiply to 24 and add to 10. And that's going to be 6 and 4. So 4x squared plus 4x plus 6x plus 6 equals 0. So 4x x plus 1 plus 6 x plus 1 equals 0. So 4x plus 6 x plus 1 equals 0. So x equals -6 over 4, which is the same as -3 over 2, or x equals -1. And it's the exact same answer as we got from completing the square. So now on to the proof that I was telling you about. Well, the formula doesn't actually use any numbers. It just uses a, b, and c. So on our quadratic, let's just write it like that. Ax squared plus bx plus c equals 0. That's a standard form for any quadratic. So let's solve the square here. What exactly are we going to do? Well, first of all, we're going to take out a factor of a. That's going to be x squared. And we're going to divide b by a. Because if you look at our previous working out over here, we divided the 10 by 4. And that gave us 5 over 2. So similarly, here we're going to do b over a, x. And then we're going to add the c, equals 0. And now what do? A x plus b over 2a squared minus b squared over 4a squared. And why did I do that? Well, because equals 0. Because similarly here, I halved this and put it there, just like here, whereas 5 over 2 is 5 over 4. I halved it and then subtracted that squared. B squared and then 2a squared. I subtracted that. And now, what's our next step? Now we can multiply by a. So we get a x plus b over 2a squared, subtract ab squared over 4a squared plus c equals 0. And now what do? Well, a x plus b over 2a squared. So we can cancel out one of the a's here, minus b squared over 4a plus c equals 0. Well, this c, what does that equal? A x plus b over 2a, get rid of this, all squared minus b squared over 4a, what does that c equal? Plus 4ac over 4a. Because if we factor out 4a, we just get c. So these are equal 0. And that means that a x plus b over 2a squared equals, so we add this to this side, b squared over, so b squared over 4a minus 4ac. Because we subtracted 4ac over 4a, and we added that, and we just put them over the same fraction. And now we can divide by a. So we get ax plus b over 2a squared equals b squared minus 4ac all over 4a squared, because we divided this side by a. And now we can square root x plus b over 2a equals plus minus the square root of b squared take away 4ac all over 4a squared. Well, what do we do now? X plus b over 2a equals plus minus square root. And in the square root, what you have to remember is that b squared minus 4ac over 4a squared is the same as b squared minus 4ac multiplied by 1 over 4a squared. Because this is going to go under it, just like here. So, armed with that knowledge, we can say that x plus b over 2a equals plus minus root b squared take away 4ac multiplied by root 1 over 4a squared, because we can split the radical into this. And then we go up, x plus b over 2a equals plus minus root b squared take away 4ac. And then this, we can just simplify this to multiplied by 1 over 2a, because the 4a squared, root that and you get 2a, and 1 square root of 1 is just 1. So now we're getting quite close, and you might start recognizing this. X plus b over 2a equals plus minus the square root of b squared take away 4ac over 2a, because 1 over 2a, we're just putting that under here. And now final step, x equals plus minus square root b squared take away 4ac over 2a subtract b over 2a. And if we put the b at front, we get x equals negative b over 2a plus minus root b squared take away 4ac all over 2a. So plus. And then we can just put that all over the same fraction. So x equals negative b plus minus square root b squared take away 4ac all over 2a. And there you have it. This is just the quadratic formula, the one that we're all familiar with. And as you see, it's basically just the same process of solving or completing the square. But it's just condensed into a formula, so you don't have to do all of that working out. Hopefully this has opened your eyes a bit and widened your horizons. And in all honesty, this is one of the reasons I love maths, is because it all makes sense. All maths is interlinked. So hopefully this has been interesting, and thank you for watching if you're still watching.